Hey guys, today we're going to look at vector and parametric equations, this time in R3. We're also going to introduce something called the symmetric equation. Okay, so to begin with, let's look at the vector equation. And so this is, of course, in R3, which is the difference from what we did before, where it was only in R2. And you'll notice that it looks actually exactly the same. Okay, and it basically is exactly the same. We just have a third dimension. So this R here, this is the position vector. Whoops, that's the erase button. So position vector of a generic point. So it's the position of any point basically on the line, P on the line. We had the R0 here, which is the position vector of a specific point. So this is the one where I gave you a point to start with. Specific. I can't spell specific. There we go. All right. Let's see. We had the U, which is the U is a vector parallel to the line. Okay, to the line, parallel to the direction vector, I guess is what I want here. Direction. Okay. So this is that's the U is what tells us what direction we're going once we start from that point, and then of course T is the real number corresponding to a generic point. Okay, so T is just a number. If you want a different point on the line, you just change the T and it'll give you a different point on the line. Okay, so we're going to find two equations. Well, I'm just going to find one, and you can find the other one on your own. Well, no, I guess I'll do them both. All right, so to begin with, we're going to find the U, okay, which in this case we'll find AB. You could, of course, use BA, but we'll use AB, okay, which is just going to be, so we're just subtracting the two different parts. So that's going to give us 1, -3, -3. And we're just subtracting the x, the y, and the z's, okay? So once I've got that, I can just say, well then, so we'll write 1. Our first one is R, which is equal to, so we start with a point, and we'll start with point A, okay, which was 1, 2, 3, I think, right? 1, 2, 3. So we start at point 1, 2, 3, okay? And then we add T times, and then we add this position vector that we just found, which was the 1, -3, -3. Okay. And then to find another one, we can just use B as our point instead. So B is equal to 2, -1, and 0, I think. Okay. And then we'll add S times, and we can actually use the same direction vector because it's going the same way. And now for each of these, I must do this, and then for this one we'll do an S, and there we go. Okay, so we got, so we got the point that we start at is right here, and then we just take this as our direction vector, okay? Or alternatively, we just start at this point, which should still be on the same line, and go that way, okay? All right, so I'm gonna leave example 2 and 3 to you to try out, and we're gonna jump on to this next part. Oh, for crying out loud. Oh, I keep doing it. All right. There we go. All right. Okay. So, a line is parallel to the x-axis if, let's just zoom in here, if the direction vector U is equal to, so we want it parallel to the x-axis, so it's just going to have an x component to it, but then the y component and the z component are both going to be 0, okay? And this is where that x component is not equal to 0, okay? The line is also perpendicular to the YZ plane. Okay, sorry, I kind of, let's do that. There we go. Okay, so the YZ plane, this is going to be perpendicular to it, okay? So if you wanted a line to be parallel to the YZ plane, then you would just have to have a direction vector that has no x component, but does have a y component and a z component. Okay? And then, of course, neither of those can equal 0. Okay? And there we go. So that's that. So let's jump over and let's look at these symmetric equation things. Okay? So first of all, parametric equation of a line may be written. So I can break up that same equation that I had before, and I can say x is equal to, when we had x0 plus t times the u component, or sorry, the x component of u. Y will have y0, t times the y component, z. Oops, yeah, no, that's right. It's just sloppy. Oops. All right, so this was our parametric version of our equation of the line. Okay, so you can see this represents the starting position, and this represents the direction vector. Now I do have to add that t is an element of the real numbers. Okay, it is important you don't forget that. But what we can do is we can actually rearrange this and get something a little bit different. Okay, what we can do is we can take each one of these and we could say, well, I have x minus x0 is equal to t ux. Okay, and then I could have the same thing for the other components, just like that. So all I've done is I've moved that position vector. I've just moved it over so it's on the other side. And what I can then do, so let's just do that, is I can redo that again, and I can actually get that x minus x0 over ux is going to equal t. But what I can actually do is I can also say, well, hold on, the same would be true for y. If I do that, that also gives me t. Whoops, that's supposed to be a y. Okay? And the same is true for z, and I am actually running out of room, so let me zoom in and see if I can get a little bit more space out of that, because I do want to say that all of those are going to equal t, and that is where t is no element of the real numbers. Okay, and that funny looking thing, it's a kind of a weird way to write out an equation, but that is just our symmetric equation. That's what that's called. And you don't actually have to include this part here. This equals t, that can be disregarded. You don't actually need that. That's okay. Okay, we do actually have to say ux, uy, and uz do not equal 0 because we'd be dividing by 0. Okay. So we're going to convert this guy right here into our parametric and symmetric equations. So first of all, let's do the parametric. Okay. So we start with x. X is equal to, and what do we have? So we say, let's see, so it's 0 plus negative t, 0 plus negative t, which is just negative t. Okay, y then is 1 plus 2t, and then the z would be the negative 3 plus 0t, so we can just say negative 3. Okay, and that's where t is an element of the real numbers. And so what we can do then is we're going to convert that into our symmetric equation. And so again, so on top you're just going to have your variable. Okay, so we'll do this. We'll have our variable, and then we subtract the initial point, which for x is nothing. Okay, and then we divide by the direction vector, so it would be negative 1. Okay, so that's equal to y, okay, minus the initial point there, which was the 1. That's this one right there. Okay, and then we divide by that. Whoops. There we go. Okay. And then finally, well, actually, so this one's kind of a funny one, because then we would have z plus 3 over 0, but of course you can't have z plus 3 over 0, so that's not allowed. So in actual fact, what we do in this case, so I'm going to write this in red. I'm going to write this in red as equals z plus 3 over 0, which you are not allowed to have. So as soon as you have that, you just disregard that, just leave that part out, and then what you do is you just include the information we have about z, which is that we actually know that z just equals -3. And it will always be like this. If you have a divide by 0 problem on these ones, it's just going to be that z is equal to a constant. Okay? So I do want you to try example 5 on your own, and we're actually going to skip this equivalent equations thing for now, and if we have time, we're going to come back to that. Okay? But for now, until next time, go Sabres.